Hello and welcome to this Java programming tutorial. Today we're going to be talking about something called object-oriented programming. And to discuss that, we're going to go over two key features of object-oriented programming, and that is objects and classes. And as we do this, I'm going to go over a little bit of the Java language simultaneously and talk about, the syntax and the rules of the language. So first off, you're probably asking, okay, what's object-oriented programming? And that's just using objects and now I have to explain what an object is to do things. And an object is just something that, say, we model in the real world. Like looking around me, I can see that there's like a desk or a lamp, and outside there's some trees. Well, in code, I can model the properties and the behaviors of those objects. And how do I model that? Well, to model it, I use something called a class. And the class is how I define that blueprint, we'll say, for the object. That's how I define the properties and, say, the functionalities of all those objects. Before I create the class, I cannot create the object. But the point is, a class by itself doesn't do much. It just sits there waiting to be, we use the word instantiated into an object. So I have this animal.java file, and in Java, all of the code that you write is placed inside a .java file so that the compiler knows, hey, I'm trying to write some Java code. And actually, all the code that you write in Java is encapsulated inside of a class, inside of one of those blueprints. And that's one of the features, I guess you could say, of the language, is it doesn't allow you to write any code outside of a class. So the class for this animal file actually has to have the same name as the file. And all the code that I write inside here is going to define the blueprint for my animal. So we're trying to model an animal class, which will eventually become an animal object. So we have to start to think about what kind of properties does an animal have? Well, let's reduce the scope of what an animal can be a little bit. And let's just assume the fact that all animals have legs, okay? But how many legs? So we want to store that as some sort of a number. So to do that, I'm going to use an integer. That's how I say number, which is just, the counting numbers. 0, 1, 2, 3. And then I'm just going to call the variable that's going to hold that information legs. I'm not going to initiate those values yet. I'm going to do that when the object is actually constructed. But I'm going to create this legs placeholder to say how many legs this animal is going to have. And let's reason a little bit more about what an animal may or may not have. Well, it may or may not have fur. So I'm going to create a boolean variable which can hold true or false values to say whether or not this animal can have fur. I'm just going to call it has fur. And I'm not going to initiate it yet. I'm going to do that once again when we actually build the object. And let me just save this. What functionality might an animal have? Well, maybe it has the ability to make some noise, like its cry. So I'm going to call that function cry, for instance, and that's how the animal is going to talk, basically. And I'm going to write a few keywords here. Just ignore what those mean for now, but just know that I'm adding behavior or functionality to this animal. So it's going to be called cry. Inside here, I'm just going to add the ability for the animal to print out some information to this console here. So in here, I'm going to say what the animal, I'm just going to say that the animal is speaking. Or the animal has spoken, because once this function runs, it's going to be past tense. And then let's add another function in here. We'll say walk, and this is going to do something similar. And in here, I'm just going to say the animal walked around. Whoops, let me make sure that's saved. Okay, so now we have some properties of our animal object, and we also have some functionality here that we added to it. You know what? Let's add one more example to here of a class, and just so you can really see how this like real world modeling thing does, I'm gonna create another one um, right here. New file. I'm gonna call this lamp.java because all the code that we write goes inside a Java file, and I'm going to do the same deal. So because it's a lamp file, the class has to be lamp. And then I'm going to add some more properties to it. I'm going to add another variable. It's going to be called wattage. It's going to be a double. And I'm going to add another variable called on, which is going to be a boolean, which will say whether or not the lamp is on. And what else could we do? Well, I'm going to take it one step further. I'm going to give this lamp a color, just to show you that these don't have to be just primitive data. Um, and I'll add color like that. Now, color is like a special thing inside of the Java library, so I'm going to have to import it. So I'm just going to do that. Public import java.awt.color. You can see it auto-completed because it knows I need to give it some color. And I guess I'll add one more thing. I'll add a height in inches. Height. Oh, I see. This is actually corresponding to a switch statement. That took me a second to get. It's a reserved word in Java, so you can't call anything switch like that. So I'm going to call this toggle. It's going to mean the same thing. We're going to switch the lamp on or off. And so we can actually provide some functionality to that will actually affect what these variables do. And I guess I'll go ahead and do that right now. So we're going to add something called an if statement here. And this is just to define some branching behavior. So in one situation, you might want the code to do something, and then in another situation, you want to do something else. So to do that, we're going to say if to do the one thing, if the thing is true. Otherwise, we're going to do the other thing. That may be a little bit confusing how I explain that, but it's to if statements are used for branching paths. So in here, I'm going to make this the simplest if-else statement I can. So in here, we're going to say if it's on, then we want to turn it off, right? So then we'll set on equal to false, which is how we're going to define something being off. Else, in other words, if it's not on, then we're going to set it to on. So we'll set it to true like that. And that's all this toggle is going to do. Let's go back to our animal now. Let's switch gears back to our animal. We want to be able to build this animal object. So I'm just going to do that here in this runner class. Don't be too concerned about the specifics of this. Exactly how this function I'm about to write is implemented. But just know that this is the starting point for where our program is going to run. And I have to make sure I don't forget that class word so that it knows that I'm typing inside the class. And then I'm going to try and create an animal just the same way that I created those other data types inside of the animal class, like this legs and has fur. I had to give it a type first. Well, I'm going to give it the animal type in this case. And then I'm also going to give it a variable name, just like how I gave this legs and has fur. So the type is going to be animal. And the variable name can be pretty much whatever I want. I'm going to call this animal Charlie. And now I have to give Charlie an animal object, right? This is just a blueprint. This is also a blueprint. So how do I do that? Well, I need to tell the program how to build the object from the class. And to do that, I'm going to use something called a constructor. And constructors, this is a constructor here, have the same name as the class file that they're defined in and as this file here. So you see it 3 times actually. It's interesting. Um, So right now this constructor doesn't do anything, right? It's just an empty function. So that actually works. We can use that, but our animal is not going to be that interesting because I haven't told it specifically what values to give this data in here. I haven't told it how many legs it needs to have or whether or not it needs to have fur. So let's do that quickly um, because I'm telling it how to build our object. So I'm going to say, well, you know what? We can actually go simpler than that. We don't have to say this. Let's say legs, and then let's pretend that this animal is a dog. How about that? So I'm going to give it 4 legs, and do dogs have fur? Yes. So I'm going to set that equal to true. And then we're going to attempt to run our object and do some stuff with it, because an object is like the actual manifestation of our animal class. Before we create the object, we can't do anything with it. These are just sitting here waiting to be used. All this data in here, all these functions and these variables in here. But now we can actually access them. So why don't we make Charlie cry? Okay. So now I'm going to compile and run the program. So to compile the program, I just say Java C because I'm already inside the same directory as where all of my code is. And to verify that, you can type ls. I compiled some of this earlier when I was trying out this example, so that's why I already have these class files in here. But I'm just going to compile these Java files. And to that, I say Java C, which is the command for Java compile. And then I put the name of the files I want to compile, which are the animal file and the runner.java file. Okay, so that's good. That means there were no compilation errors. And then to actually run it, I put the name of the program of the file that actually has the starting point for our program, which in this case is the runner. So I just type in runner here. And then it runs the code. So it creates the animal object behind the scene. There's no output for that because this is just constructing the object. And then it cries, which calls this function here. And just like that, the animal can speak. It prints out some output to the console. Okay, next let's make the animal walk. Next, let's make the animal walk. So I'm going to say charlie.walk. And then I'm going to recompile the program. I can just tap the up on the arrow keys, and that'll let me access the previous commands. I'll go back down to Java runner. And now the animal walked around. Okay. What if we want to add some more properties to this animal? What if we want to give it a name that is going to match like the variable name that we gave it? Well, I could add another, they're called fields here. I could add another field here, another variable to my animal blueprint so that he can hold a name. And I'll just call that name. It's going to use a special data type called a string, which is just words. For now, we can just think of those as words. And I'll just say something like that. And that just means that now this animal can take in a name and store it in the name. So I'm going to make this a little bit simpler though. I'm just going to call it name parameter because I don't want to confuse you with some extra syntax. And I'm going to set name equal to name parameter. Now when we build our animal object, we're going to pass it a name and it's going to get set to the animal's actual name. Okay? So I'm going to do that here. And it's complaining now because my constructor now takes a name and I haven't provided one for it. So I'm going to give it a name of Charlie. So now when our animal gets built, Charlie gets set in here as name parameter and it gets set equal to the name. So what if we want to use the name field? So I'll just call this display name, and all it's going to do is going to print out this animal's name. And in here, I'm just going to type name because it knows I'm talking about this name right here. And I'm going to call that function, and it should print out Charlie. Let me recompile my program, run it, and as you can see, Charlie got printed out. Okay, great. I think our animal's looking pretty good right now, so let's go back to our lamp example. So, I've defined all these properties for a lamp. Its wattage, whether or not it's on, its color, and its height. Why don't we provide a constructor so that we can actually build the lamp? I'll follow the same template that we were kind of doing here. I'll create a lamp here, and I'm going to call it, what should I call this lamp? I'm going to call this gray lamp because eventually we're going to add some color to it. And now I need to be able to call a constructor function on it. So we don't have one yet. It does provide one by default, so I can actually do something like this. Believe it or not, because Java's smart enough to know, hey, you've made this class. I'm just going to give you a default constructor that does nothing. But we want to explicitly say exactly how we want it to build the object. We want to tell it how we give it wattage, whether or not it's on, the color, the height. So I'm going to do the same deal. The constructor has the same name as the class itself. And then I provide information for all of these different fields. I provide data for each variable. So I'm going to say the wattage is going to be equal to 20. And I'm using a decimal there because that's what this double holds. It holds decimal values. I'm going to set the lamp to be off by default because, I mean, most lamps are. And then I'm going to set its color equal to be the special thing, color dot gray. And I'm going to give it a height. The height of this lamp that I'm looking at here is about a foot. So we'll say that this is measured in inches. So that's 12. And I'm just going to leave a little, this is called a comment. It's something that the program doesn't care about really. It's something that the compiler doesn't look at. It basically just ignores it. It's for our own use so that we can remember special things about our program. And I'll just say height is measured in inches to remind myself. Like, whoa, like that. So now we've defined how to build our lamp. So let's do the same thing over in our runner. I'm going to call some functionality on it. So when we build our gray lamp, we're making it off by default. So I'm actually going to change this statement here. And I'm going to just print out whether or not the lamp is on or off. So I'm going to do this. The lamp is, and then I'll put on here. And on is either true or false. So once it does the switching, it's going to tell us whether or not the lamp is on, okay? And this if statement really isn't that complicated. It just says if it's on, if that's true, turn it off. Else, if it's not on, turn it on. That's what that means. Which is how you would want a lamp switch to work. So in our gray lamp, I'm just going to call that toggle function. Which should print out whether or not the lamp is on. But first, let's make sure that the lamp is on or off. It should be off because we're telling it that on is false at first when we first construct our object, which is what we did right here. So I'm going to print out the on field here. I'm going to wrap this in a print. And I'll say, is the lamp on? And we expect this to be false. And then once we toggle it, it should turn the lamp on. So I'm going to compile our lamp program, and I'm also going to recompile the runner. So to do that, I'm going to type the names of both of those .java files. There are no errors, which is good. No compilation errors that came out. So now I'm going to run the program. And It did all of our animal stuff because it's still sitting here. And then on line 8, it started doing lamp stuff. Is the lamp on? False. Oh, and let me edit this if statement here. This toggle function. Like that, so it's more clear. Let me recompile and run that. Oh, forgot to save. Let me recompile and run. Okay. Now, what happened? We create our lamp object, which set on to false. That's what's happening here. And then we asked, is the lamp on? And then we displayed whether or not the lamp was on. And then we called this toggle function on our lamp, and the lamp switch was, if it was on, we turned it off. Or if it was off, we turned it on. In this case, it was off. So when we called toggle, it turned the lamp on. You following that? Okay. Um, Maybe we can fill in some more of the properties for the lamp or do something more with it. We can add some more functionality to it. So let's just say I want to know how tall this lamp is. Well, it's simple if I just want to access that data directly. If I were to print out that information, it would let me. So I could print out the height. Same way I printed out whether or not the lamp was on, and it tells me that the height of it is 12. Um, what if we wanted to show what the color is? I'm going to do color, and we should get gray here. What was output here is actually the RGB color values for gray, which is 128, 128, 128, right? All these different intensities create the color gray. That's what the toString function for a color does by default, which I can explain in another video. Uh, but the point is, we're able to get information about the color when we just print it like this. What if I wanted to make that information to this lamp private, as in I don't want anybody else to be able to see the color? Well, I could just add that, and now color is only accessed internally here. Nobody else can see it. So as you can see here, this is highlighted because it's not visible. It doesn't know anything about that color. And then I could do something called a getter, which is going to let me access that information about the color of the lamp. So it's a function, and it has to be public. And it has to be of the same type, obviously. Which is kind of getting into things that I haven't really explained yet, but now it's going to allow me to access that color. I just have to call that getColor function. Okay, so now if I do it again, it's going to give me the same information as before. Even though this color was private to the lamp itself, I can still create a public function which will return that color back to me. And there are a bunch of advantages of doing things this way and also some disadvantages. This is referred to as encapsulation, which just means making your code more compartmentalized. I only allow this color to be used within the lamp. If I want to get information about it, I make a public function to return the color. This way I can control more what data is going in and out of my program by making this private and saying exactly how I want to return it. I may make it so that every time I return a value, I want to print out some information. Now if I call this getColor function, it's going to print out that print statement the getter was called. Maybe that's something I would like to have my program be able to do. Okay, so I've covered a lot of things here. I covered what classes and objects are, how to define the properties, how to define the behavior for a certain class. We did the same thing here. And then I said I can define how to construct that object from the class, exactly what values we want to go inside these properties. For instance, we want to give the wattage a value of 20 when it's constructed. And then I actually did the building here. I defined the type of it and a variable name, and then I set it equal to a new object. Same idea here. Type, variable name, I set equal to a new object. And now we can actually do stuff with it because the class is just the blueprint, but the object is how we use it. Alright, so I hope you enjoyed this video. Leave a comment if you want to see more, if you have any questions, especially if you have any questions. And then in the next video, we'll tackle some more object-oriented programming concepts and some more Java. See you then.